Hi everyone, welcome back for another weekly update. All right, so I'm already sharing Canvas. I'm gonna navigate to the modules, and as I mentioned last week, good job because we are making good progress, and I know it is a lot of work, so well done. We are about to finish off our Unit 2. So we have the last assignments for the last three chapters of Unit 2 that are due on July 6th. But that also means that what we have coming up next week is our second exam. All right, so you can check out the second exam's information here. Essentially, you can see that it's the same as what we saw for the first one, except that, of course, we are now covering different chapters. So you have the topics shown here, but of course, you have more details as you go through the content of each chapter. But otherwise, you can see, of course, also the updated timeline. It's going to open again on Monday at 9 a.m. and it will be available through Friday midnight. You will have two attempts, and once you start each attempt, you'll have 3 hours to answer 35 multiple choice questions. Just like last time, you have access to um, this uh, practice exam. So again, this is something that you can, try out. I think up to 99 or 100 times. So I don't encourage that, but essentially you can take it as many times as you want. And I would say, once you've completed, all of the chapters of Unit 2, before you take the actual text, I would encourage you to try out the practice exam. Um, and so once you're happy with your practice test, then you can move on to the actual test. And once again, two attempts, and I will keep the highest score. So, unless you're very happy with your first attempt, that's great. But otherwise, taking it a second time doesn't cost you anything because, again, I will keep the highest score of the two. So that was the first part for this weekly update, another important one. This is exam 2 out of 3. Again, as we're moving through our summer, and again, we only have a few weeks together and so much material to cover. But as I said, you're doing a great job. I'm going also, checking your assignments, and it's really nice to see your engagement and how you're completing all of these tasks, even though I know there's a lot of them. So part two of this video is looking at the upcoming new content that we are also going to cover next week. So as I just mentioned, we're essentially done, except for exam 2 with unit 2, which means that we're now moving on to unit 3, and this one is called classical physics. And with this one, so usually you'll see that, it's classical versus what we'll see later with Unit 4, which is called modern physics. And we'll see that we'll revisit some of those things that we've talked about already in the context of modern physics. But for now, we are going to be interested in our Unit 3, and we are going to cover two chapters this week. Chapter 8 on thermal physics. Sometimes that's also called thermodynamics, and chapter 9 on electricity. Just really quick, as we overview our unit 3. After that, we will talk about magnetism in chapter 10, light in chapter 11, and that will be the end of unit 3. Really quick, also as an overview of Unit 4, again, it's July and, we'll essentially go through the end of the month and that's it. So things are going to be moving fairly quickly. For modern physics, we will have, 3 more chapters to go after that. Um, so, all right. And just also because Unit 4 will be covered in the last week. There will not be an exam for that one. So all of your assignments for Unit 4 will come down to your homework and discussions, and activities that you have in that chapter. But if you're like, oh, there's no exam, is it missing? No, it's just that we're only going to have 3 exams. Again, to make sure we can fit everything within the weeks that we have together. So, um, all right. Okay, so for what I was saying, this coming week, we are going to cover chapter 8, chapter 9, and so now I'm going to navigate those two real quick with you. Again, there is, I mean, by now, right, we're on chapter 8, so that means that you've seen quite a lot of chapters with me and you know how they're organized. So same as before, we start with a little overview, then we, take a look at the learning outcomes. So again, thermal physics, we are going to introduce some new concepts and for this one, I would say I know some of you have taken chemistry before. That will most likely be very helpful here, because this is one of the chapters where there's a lot of overlap with chemistry. I would also advise you to be careful with the units. If you've already learned some of this in chemistry, chemists and physicists don't always use the same units, so that might make things confusing because, um, for example, some of the constants that we use, they will look a little bit different again because we use different units. So just something to you know, be aware of. The way, the concept themselves and how, those principles that we describe, obviously, it's still the same just because you see them in chemistry or physics. It doesn't change the actual science behind it. But just sometimes the notations and the units can vary. So the first thing we talk about in this chapter is temperature, because this is going to be really important in describing a lot of the processes and states, thermal states, that we're going to talk about. And with temperature, we're going to talk about different scales, and how to do the conversions between all the scales. And then we're going to talk about the laws of thermodynamics. And as we do that, we're going to introduce things like the concept of, heat in the concepts of physics. We're going to use pressure quite a bit, uh, and again, it's things that will be familiar if you've taken chemistry before. Um, this is again a very important chapter. It may be obvious the reasons why, but you will see a lot of this is one of the chapters where a lot of students find a lot of applications to everyday life. So if you like to cook, But even if you like to enjoy, like a hot beverage like coffee or anything like that, heat transfer and things like that will come into play. Even things like, you look at your water bottle and how it's built, and transfer of heat and how we isolate things is definitely something that we're going to talk about. But there's also things like understanding how AC or refrigerators work, are important applications of this chapter. So lots and lots of applications in your everyday life. Um, all right, so this is again some videos. I should move this, but this is one of the homework questions that I've worked through, that I posted here, and a lot of, you know, videos that you can watch. If by now you probably recognize, right, the Hewitt Druitt or the Crash Course Physics videos, and you can pick the ones that you enjoy or skip over the ones that you don't. Um, like with every chapter, we have our pre-chapter check again, especially if you've taken chemistry, that's a good, thing to do if you want to see, what type of questions we're going to go over or try to answer here. All right, so many types in this one, so watch out. Here, we talk about temperature and heat. Then we go into the first law of thermodynamics, the second and third laws, heat capacity. So there's a lot we're going to cover. Latent heat. Um, and again, this is when we look at transfer of heat and how that can give you a change in temperature. That can also give you a change of state. So a kind of a common example is with water. Like you could start with ice and cook that up, and then that will turn into liquid. And if you keep bringing heat to that, it will end up in vapor, etc. So here entropy, and then there's another solution to another problem that you have given over here. Um, so again, make sure that you check out all of the tabs. You have the slides handout given again, and uh, another, thermal expansion is another important one. Um, and lots of if again, things we need to take into account in engineering and building buildings and bridges and things like that. So that's something else we'll talk about. So as usual, you have your homework set for that chapter. And then for this discussion, we're going to actually, so no videos or simulations for this one, but you have a number of links that will give you different examples of how nature regulates temperature. So another example of application or like everyday sort of uh, uh, applications for what we're going to be learning in this chapter. So the idea is to explore, so you can explore those links that will give you a number of examples, or if you know of another one, you can pick that instead. And so you don't have to go and do a whole analysis of all of the examples. The idea is to pick one example that you again find in one of those pages, or that you're aware of, or you can look for others. And So once you pick your example, you have to explain the mechanism responsible for regulating temperature. And please use physics concepts that we use in this chapter as much as possible. And yeah, that's it. So a lot of the examples that are given here are from animals and plants. Um, they're really fun, I think, to learn about. It's really interesting how, nature. So nature meaning like all the plants and the animals and have found ways to evolve to figure out, how to live in sometimes, places that are either very hot or very cold, or with a lot of, temperature changes and how they've adapted. So again, you'll find some examples here, and it's always fun to learn new ones. So yeah, so pick one example and then describe that. And as always, make sure to comment onto other posts. It could be that we have a very large class, so it's very likely that some of you will share the same example. So you can comment, if you noticed something else that somebody had, if they picked the same example as you, or just say, hey, like I also enjoyed reading about, or learning about this particular animal or plant. Um, all right, so that's it for the for chapter 8, and now we can move on to chapter 9 on electricity. I probably don't need to explain why this chapter is also very important. We are very, reliant on electricity. So the reason that we're able to do this course online is because we have electricity and we can use our computers. And so again, lots and lots of applications in your everyday life of this particular chapter. And again, just like this, I've had to take classes, more advanced on like chapter 8 that were semester long. Pretty much the same. So usually electricity and magnetism are put together, and we'll learn more on why next week. But again, that's something that we could discuss for many weeks. And so this is really an overview and really focusing on the concepts. But again, very important. And as we go over electricity, we're going to first try to understand what electricity is. And that means actually starting with electric charge. So that's a very important concept as we move forward. So we're going to talk about electric charge, and we're going to talk about how electric charges interact. So this is going to be Coulomb's law, very important. We're going to talk about the concept of electric force, electric field, and we're going to see how an electric force is going to have an effect on an electric charge, or how an electric charge can create an electric field and things like that. So, um, with this chapter, I would say, even though we have so many applications, right, in everyday life, this is where things can get more difficult to picture, because we don't see them, right? I mean, we see lightning, but you plug in your computer and, or you charge your phone, but it's much harder to picture, right? An electric charge, an electric field. So we're going to try to understand how it all works. We're also going to talk about the basics of electric circuits. Again, very important because, again, the way your computers or phones, etc., electronics work is thanks to like more complex circuits that what we're going to talk about, but understanding the basics is important. So we're going to define things like electric current, how we measure it, voltage, how it connects with current, resistance with Ohm's law. We're gonna figure out, different types of simple circuits, especially like, talk about things like circuits in parallel or in series, and you know, also just, being careful. So how electricity can have an effect on the human body if we're not careful. So, again, so much to cover, right, with this chapter, but also very, very important information. So, all right. So, as always, with our crash course physics videos and more. So, again, with these videos, it's also trying to help, kind of see what's going on when we often actually can't really see. And we'll see why also with the discussion for this week, for this chapter, we're going to take a look at a number of simulations to help really put these, like, things that we can't see in perspective. All right, so here are the lecture videos with, so again, defining electric charge, force, field, how they all interact with each other. Then electric potential versus electric potential energy, which leads us into electric circuits. So this is going to deal with like voltages and then building a simple electric circuits. And then you have additional help. So again, where there's some solution. So I would be careful. Sometimes the labels are not quite right. I should rewrite those because this is obviously chapter 9, but we deleted the textbook, and as we did though, that the chapter numbers changed and the questions, but you can review this also to go through like a step-by-step answers to some of those questions um, that you have in your homework that is coming up on the next page. And then as I mentioned, for the discussion, we are taking a look at three simulations. You don't have to use all three. So I would encourage you to explore all three, but you can pick one for the discussion. So I will show you briefly all three. And then the idea is to pick one and make an observation about electric charges that you'll see in the one that you pick, their interactions, and describe what you see. And as always, reply to two other posts. So you can see we have one called Balloons and Static Electricity, one called Electric Field of Dreams, and John Travoltage, which is, so, a play on words for John Travolta. You'll see why. So we're going to start with balloons and static electricity. So this is what you'll see when you first start things here. We have a sweater here. We have a balloon. There is a wall. I'm going to use words that you may not be, familiar with yet because you have not seen the chapter, like the lectures and etc. yet. But the plus and minuses represent electric charges. You can see that everything right now is neutral because for each positive charge, you have a negative charge. So the overall is 0. But what we can do is, for example, take the balloon and we'll see that if we bring the balloon over here, it will pick up negative charges, which turn out to be electrons. And then now things are no longer going to be static because now it's going to, so now it's negatively charged and our sweater is positively charged. And so they're going to now attract each other. I can bring it to the wall and we'll see something interesting happening. So the charges are not going to come off, but this is also going to stick because the negative charges on the balloons are going to push away the negative charges over here. So overall, we're actually closer to the positive charges, and this is also going to create an attractive force. So you can do a number of things. You can show the charge difference if you prefer, but I like seeing the all the charges. You can add a balloon, you can reset the balloon, you can remove the wall. So, you know, so you can play around with this. But that's basically it. And then for this one, this is Electric Field of Dreams. So this one, I would say a bit more complex. So for this one, you can add or remove. So add is going to be adding a charge. So here, I'm adding an electric charge, and you can see that now we have these arrows that are going to represent the electric field in this space. So now we have an electric field because we have an electric charge that is creating this field. So these lines are representing something we call electric field lines. And I can add another one, and we can see that now they're essentially the same. So they're going to repulse each other. And so you can do a number of things here. This is a negative charge, and you have a given mass. So you could add charges with a positive value. You could change the value of the charge and see how it changes your field. But you can see how they're interacting, and you can reset everything, start over, add more, and describe what you see. All right, and the last one is John Travoltage. Um, I'm not going to do the whole simulation here, but I will show you what you can do. So you can see that I can move his arm. Nothing's happening right now. The other thing I can move is, so this is similar to the balloon because what we're doing is essentially through, um, so we have a rug here, and essentially John Travolta is acting like the balloon, and through friction is picking up negative charges. So I can keep doing this. This is the same as essentially taking the balloon. You can do that on your hair and things like that. You will pick up those negative charges, and then I will let you see what happens then when you put your hand on, you know, the door there. So I leave it up to you to try it out because I don't want to show you all of the, I need to leave some suspense here. So, um, but that's basically it. So here, charging up John. Sorry, then you saw because I charged it too much. So we built up the charge, but you could try to see also how much charge you need. So why is it that this is not traveling? Anyway, so um but that's essentially what you can do with this one, but you can try, to see how much charge, how close you need to be. Why is it is nothing happening right now? Versus like if I build up the charge, etc. So and you can create some lightning there if you want. So, and that's it. So this is it for, these two chapters plus the exam. So again, a busy week coming up. But you can see that once we're through, with just a few weeks we have left, again, amazing because you will have completed Unit 2. And then the week after that, we will go over two more chapters of Unit 3, and then that will be at the end of Unit 3, and then we have just 1 week that is going to cover Unit 4, Modern Physics. So well done. Keep going. You're doing amazing. And, please don't hesitate to reach out if you need anything. All right. Thank you so much. Bye.